We're looking at angles and polygons, and so we're going to be looking at, how much are these angles inside these things worth. If we extend a side out like this and create this exterior angle, how much is that worth? And then we're going to ultimately be looking at something like this, where it's kind of an outside angle created by two polygons going together, and we'll just kind of think that through. Here's a hint. We know that that's 360 degrees. Here we go. First up, vocabulary. So go ahead and put me on pause, get your vocabulary sheet out. Let's start writing it down. You just simply copy it as we go. So we have polygons, concave polygons. Convex polygons, the vertice, if you look right here, the vertice, it has a point. Each one of these is a vertice on these figures. And the sides, when they go together to form that, or from that vertice, they always point outward. If you look down here at the concave, the red line shows you that's kind of pointing inward in those cases. Regular polygons are simply polygons where all the sides and all the angles are congruent. Now, I'm not saying that sides are congruent to the angles. That's impossible. Sides and angles can't be congruent to each other. They're two different kind of shapes, but the sides are all congruent. So if you look at my little green arrow there, it's pointing to a regular polygon, and in this case there's 1, 2, 3, 4, 5, 6 sides, so that's a hexagon. That hexagon has 6 sides, and they're all going to be congruent. So if one of them is 5, the other one is 5. And what we find in regular polygons is if the sides are all congruent, the angles are all congruent. And if the angles are all congruent, then the sides are all congruent. So in this case, if they were all 5s, that's great. That means the angles inside could be, let's say, 36 or something like that, and they would be all 36s. Over here in the next column there, I have a triangle, a green triangle, and you can see that that is a triangle with 3 sides that are congruent and 3 angles that are congruent. We know that as an equilateral. That was a definition word that we've had in the past on a previous video. If you didn't have that one already, you've skipped a video. So if we have regular polygons, we have irregular polygons, and that just simply is a polygon where all the sides are different, and that would also infer that all the angles are different. So there's your interior angles, or just angles inside the polygon. Exterior angles are a little bit different. They're, exactly as advertised, they're exterior angles. They're angles outside the polygon, and they're formed by extending one of the sides out. And so, as you can see in the blue figure there, I just took one of the sides, extended it with the red line, and it creates that exterior angle. So I'm going to draw another picture here, and I want you to go ahead and draw the similar figure on your paper, and then extend just one of the sides at a vertice. Just go extend one of the sides, and then do the arrow thing there to show an exterior angle. Okay, so I have this triangle here. I'm just going to take one of the sides, and I'm going to extend it. So I'll take this one right here, and I just extend it out, and it creates that other angle. Oh, whoops, I'm sorry. I should just draw there. I don't know if that's right or not. Okay, so let's go up to the vertice at the top and extend one of those sides. And so I'll just extend that side right there, and that forms this exterior angle. Notice that the exterior angle is always made up of an extension and one of the sides, okay? And then in retrospect, what we want to also realize is we're not talking about the straight angle that will always form when we do this. It's always on the other side that we're looking at. So what's kind of neat is many times I'll get students say, well, what happens if I end up this case? I extend one side, you extend the other. So let's say you took the green side and the hypotenuse, or this side over here, and you extend it and you create this angle here. And I said, well, at that same vertex, I want to extend this other side. And so I create this angle, those both being exterior angles. That's not a problem. What we find out is that those two angles are what we learned in our previous lesson is vertical angles, and they're the same. So if you extend one side and I extend another, it's going to create the same size angle, and you don't have to worry about that. Okay, next up are some formula sheet problems. So you need to pull out your formula sheet and add these to them. I'm just going to simply expose them. You're going to write them in. We're going to work with them later. So there's the first one. Just simply copy all that information in. It'll be a reference. This is what you have this formula sheet for. So once we go through the problem later on, you'll come back to that and go, oh, that totally makes sense, and that will be your reference. Just keep on copying the same information in that I have here into your formula sheet, and you're set. All right, go ahead and write in the sum of the interior angles. Just go ahead and write that in there, and you have it all set, right? Just copy the information in. We'll talk about it later. So here's the next one. This is the sum of the exterior angles, and it says the sum of exterior angles is equal to 360, and that's all day long. Doesn't matter what type of figure it is, doesn't matter at all. It'll always add up to 360. So I have a pentagon over here, and I'm just going to simply go in and write, like angle 1, angle 2, angle 3, angle 4, and angle 5. And so there's 5 exterior angles because there's 5 sides, and I just extended those sides straight out. Might not look that way, but I did my best with the area I'm working in. And simply put that if I add up all those exterior angles, they should equal 360. So if I knew 4 of them, they were given to me somehow, and I knew that they added up to 300 degrees, that would leave 60 left over for the 5th one. Okay, here we are. If we were given the idea that we wanted to find one interior angle of a regular polygon. So we'll use this figure in a bit, but it only works when it's a regular polygon. That means all the sides and all the angles are the same. So just draw that in there. So I have a little bit of an example there for you that you use later on when you come back and look at it. And so I just calculate that right-hand side to find out what x is, the number of degrees that this figure is, or has for an interior angle. Okay, and last up is one exterior angle in the regular polygon. How much is that worth? So basically I would say, hey, in this regular polygon, how much is x? And so we could find that by finding out what x is by taking 360 and dividing it by n, which is the number of sides again. And when I say number of sides, I know that same thing means the number of angles. So there's my example. Let's move on. Okay, here I have a triangle, and I've got a 20-degree angle in it, an 80-degree angle, and an x plus 5. So in your notes, let's label this triangle sum. And basically, I would see an unknown of x, and so I immediately say, hey, if there's an unknown there, I'm going to have to find it. And the best way that we have is to set up an equation. So we have to realize from the triangle sum in our formula sheet that basically we know that from the triangle sum that if we add up the 3 angles, they have to equal 180. I'm not going to do the algebra for that or the math. I think that's something that you can do. But you need to understand that when I see a problem like that, you're going to write an equation and that you're just going to add up the angles and equal to 180. All right, let's talk about the sum of the interior angles. And so we're just going to look at this figure as a 5-sided figure. And so we know that as a pentagon. And so what we want to do is add up we want to know what all the interior angles add up to be. I don't have any information about this. I don't know where an x is or if they're all congruent, but I need to discover, how many degrees is the whole thing. So I want to take a look at something. If I look at this top vertex and I draw this line down, that's called a diagonal, and I draw another diagonal down. As you'll see, there's no other place I can draw a diagonal and create another triangle. If I try to connect to this one over here, that doesn't add another triangle, that just connects the 2 sides. And if I go over here and start to draw a triangle this way, I actually end up having my diagonals cross each other, and that's not the point that I want to create. So I have 1, 2, and 3 triangles. And inside these triangles, each one of them have angles inside them. Okay, and I don't know if they're congruent, so I'll just mark them like that. Over here, I'm going to do a congruency marking like this. This is another way of marking things congruent or not. So I have a single arc, but have double, triple, and single little hash marks there. So I could come over here and I'll 1, 2, 3, 4. I just don't know if any of these angles are congruent to each other. So I'm just going to do it like this. Okay, so there you go. All right, so as you can see, in this triangle, there's 3 angles. In this triangle, there are 3 angles. And in this triangle, there are 3 angles. If I wanted to know what all the angles added up for the pentagon, I would add up those 3 angles, this angle, these 2 angles, these 2 angles, and this angle. Okay? If I knew what they were, but I don't. So I'm trying to find out how could I possibly calculate the total amount of all those angles. So what I want you to know is that in each one of those triangles from the triangle sum theorem that we just looked at, each one of them have 180 degrees embedded in those angles that they own. Okay, so each one of these has 180 degrees embedded in it. So in reality, what I find is that if I just take 3 and multiply it times 180, that will tell me the total sum. In this case, it's going to be 540 degrees. So what I want you to do is go ahead and draw yourself this figure, count how many sides, and just draw it. And then I want you to kind of do the same thing. I'll start you off. You just draw the diagonals from one of the vertices to all the other vertices that create triangles. Then take the number of triangles and multiply it times 180, and that will tell you how much all the angles inside this figure, this hexagon in this case, I believe, how much that should all add up to. So go ahead and put me on pause, and then I'm going to do the work. And then you can come back and check it. And there you have it, 720 degrees. I have no idea how much each one of these is. This big angle here, I have no idea what each one of these angles is. Okay? But what I do know is that if I did know what they were, they would all add up to 720 degrees. So one of the things that we run into as an obstacle is that if I said, hey, what's the sum of the interior angles of a 22-sided figure? I don't want to draw that. And so I need to be able to do the calculations somehow. And what best way to do that is kind of look for a pattern. So I'm going to back up at the previous drawing and show you something. Okay, here we are. We know that there's 3 triangles in there, and they add up to 540 because 3 times 108. But here's the cool thing. This is a 5-sided figure with 3 triangles. On the next one I did, this was a 6-sided figure. 6-sided figure called a hexagon, and it had 4 triangles, 2 less. So I'm starting to see a pattern that the number of sides, if I take the number of sides and subtract it by 2, that will tell me how many triangles in it. Let's do one. Okay, so here we have a 12-sided figure. I don't want you to draw this. This is just like, it's really hard to do on a paper, but this is 12 sides. I'm going to quickly draw in the diagonals, and then I'm just going to number the triangles that I just created. And lo and behold, I have 10 triangles. Just as I predicted, the number of sides minus 2 tells me how many triangles I have. So to find the sum, I simply take that 10 and I multiply it times 180, and that gives me 1080. Sorry, not 1080, but 1800 degrees. All those angles added up have to equal 180. So if I knew, 11 of the angles added up to 1,780 degrees, I know that there's 20 to be left over for the last one. Okay? So that leads us to this formula that we already put on our formula sheet, but you have to memorize. Right? The sum of the angles of the polygon is equal to parentheses n minus 2 times 180. All right. On occasion, a handful of students don't put the parentheses in the right place. I'm not going to show you where they do it, but they do it in the wrong place. And so I want you to memorize it correctly. So see where the red parentheses are? That's where you're placing them. Write this equation every time you're doing a sum of angles problem, and you'll have this, okay? You got to memorize. Okay, so we're going to be given problems like this. We're going to have to write an equation. I see unknowns. So what I'm going to do is I'm going to first do the calculation of what all that mess should equal, what it should add up to, and I'm going to use the n minus 2 equation. Six-sided figure calculates to 720 degrees. Now I'm going to just set up an equation, add in all those little pieces together. And there's my equation. Now, I know that some people are sitting in this class that struggled a little bit with algebra. Your algebra skills are going to only get better, and they will get better if you stay with me and don't get scared by such a long piece. Just do it in steps. So I simply took all the pieces and put pluses in between them. It doesn't matter where you start. Just start one place and just start going clockwise and put them together. Okay, and so I just kept it writing, and then I made it equal to the 720 that I calculated up here. 2 steps, okay? So now it's just a matter of solving that. I don't at all struggle with algebra, but you might, and so I'm going to suggest that you underline like terms. And so in this case, I underlined my x's, and now I'm going to underline my singles, and then I'll pull them together on the left-hand side and start solving this thing. That's everything on the left-hand side combined. And so I come to a conclusion that x is equal to 70. Okay? Now, sometimes they'll tell you to find a specific angle, and you just take that 70 and plug it back into whatever angle they're talking about. Okay, here's the next question that we're going to do together. I actually want you to go ahead and put me on pause and see if you can think through this. A decagon is 10 sides, okay? So you might want to start creating a list. If you don't know these names, create a list and make sure you memorize the names of them from 3 to 12. And so you just have a sheet. Some people need that, some people don't, so I'm not going to force everybody to have it. But if I say this is a nonagon, you got to know it's a 9-sided figure, okay? So now they want you to, knowing it's a 10-sided figure, to find the sum of the interior angles. That's the work we just did. So go ahead and do that calculation by pause and then checking it out. And there you have it. You should have done that one on your own and then just checked it. All right, next question is, what is the sum of the exterior angles of a decagon? And so I want you to go back and look at your vocabulary words or your formulas and see if you can answer that one on your own. Okay, I'm going to put it on pause and then you can come back and check it, see if you got it right. Hopefully you wrote 360. Every polygon has exterior angles that add up to 360. I don't care how small or how big, how many sides, it's always going to add up to 360. If there's 12 angles out there, it's 360. There's 45 angles on the exterior angle. There's 45 separate little angles. It's going to add up to 360. So I know that for some people, they really struggle with this exterior angle thing. This is just a nice little drawing showing it, okay? So basically, whatever the interior angle is plus the exterior angle, it has to equal 180 because it creates a straight angle, okay? So that's how we get it. Okay, you have only one try it problem. Make sure you have the figure drawn, and then just make sure you have an equation set up and show your calculations and bring it in nice and neat next time, okay? There you have it. Have a great day. I'll just add to that, if you're still here, that those boxes equal 90-degree angles. So don't forget to include those angles. Those are part of it. Again, have a fantastic day. We'll see you next time. I'm exhausted, and I know that you are too. You've listened for about 20 minutes, and so go at it.